So welcome everyone to this webinar on how to instrument and monitor your Java applications using Elastic APM. I'm Rasmus. I'm the product lead for the Elastic APM team. And before I dive into the actual slides and presentation here, I'm just going to go over this slide with some housekeeping. The slides and the recording will be available after the webinar. So if there's details in the slides, you can always check them after the presentation here. And we have a chat, Elastic-webinar on Freenode. If you're watching on Elastic Co, you can click the webinar chat link. And do feel free to ask questions during the presentation. There's a few team members here in the chat. I see a few of them active already. So they will be monitoring the chat and happy to answer any questions while I'm presenting. And yeah, please make sure to select high resolution on the YouTube player, little icon down there, to just make sure you get the presentation in best quality. All right, and with that, let's get started. So for those who don't know, Elastic Stack consists of these components. I just want to give a quick intro to those who might not be familiar. So at the core of the Elastic Stack is Elasticsearch. That's where you can store and search and analyze all of your documents. On top of Elasticsearch, we have Kibana. So Kibana is the visualization layer for all documents in Elasticsearch, generic visualization layer for time series data, geodata, text data, and whatever data you might be storing in Elasticsearch. And as a way of ingesting data into Elasticsearch, we have Beats and Logstash. Beats is, for instance, really neat if you want to have logs sent to Elasticsearch, or for instance, use metric beat to get infrastructure metrics to Elasticsearch. You can also use the Elasticsearch API. So you don't need to use any of these components. Elasticsearch has a great API, but they are a very convenient way of getting data into Elasticsearch for certain use cases. On top of the stack, so to speak, we are now venturing into building out these solutions, and APM is one of those. So you might have seen our search solutions and APM, hopefully. We're also building out logging and metrics solutions, like dedicated solutions for those particular use cases. And same is happening for business analytics and security and many more in the future. So do keep an eye out for those dedicated solutions. And before I get into the APM presentation, I want to mention that there's a few ways to consume the Elastic Stack. You can either download it and have it run self-managed, or you can use our hosted offering, Elastic Cloud. For those who like to use Elasticsearch but don't really like to operate it and to scale it and so forth, Elastic Cloud is a great alternative. You essentially get an Elasticsearch endpoint, and then we take care of version upgrades and scaling and so forth. If you want those capabilities but can't really store the data in the cloud, Elastic Cloud Enterprise is a great alternative. It's essentially the same software that we run on cloud, but sort of packaged up into a product that you can install and run on your own infrastructure, but still get all the benefits of single-click upgrades and so forth. All right, so with that out of the way, let's get into today's webinar and APM presentation. The main reason that Elastic is venturing into APM is really to give you end-to-end monitoring with the Elastic Stack. So as mentioned before, we already have logging, FileBeat, and Logstash. We do server-level monitoring with other beats. But now we are also providing these top brackets here with APM. So that means you'll be able to trace performance all the way from the real user monitoring agent sitting in the end user browser, and all the way down to the logs and metrics of your hosts and containers. And we believe that the combination of logs, metrics, and APM is really powerful and will be working very hard on integrating those data sources and solutions going forward. For APM specifically, 6.5 was a massive release. So if you've joined previous webinars or been following the Elastic APM product, you might have seen that Java and distributed tracing has been sort of top requests that we've been getting over the past months. And that makes a lot of sense, of course. And with 6.5, I'm super excited to say that we now have Java and Go support in GA. And we also have distributed tracing out in beta. So that's what we're going to be talking about today. And I'm super excited that we are now finally here. So before I dive into the actual product, I just want to sort of set the scene for what distributed tracing really is and why it's useful. So for those not familiar, distributed tracing allows you to link together services as they interact with each other. So what I've tried to visualize here is an incoming request coming to your architecture, to your services. And your service A might then go off and make another request to other services in order to serve that initial incoming request. And if you're only tracking one service at a time with APM without distributed tracing, you won't really be able to contextualize the performance of individual transactions. And it makes it pretty difficult for you to sort of get an overview of how an entire request is being served and where the actual bottlenecks are. But with distributed tracing, what we can do is we can link all these services together into one trace. So as illustrated here, you'll be able to see the first transaction A was called, then it generated some spans, spans here reflecting maybe a database query or cache call or whatever it might be. And then down to transaction 2 and 3. So here you have 3 services in total that are helping to serve this one request. And with distributed tracing, you'll be able to not only see all of these in this waterfall visualization, you'll also be able to jump from one to another very easily instead of having to go do that manual, which is the case prior to distributed tracing. If you have a microservice infrastructure, of course, this is becoming extremely valuable as you probably have many services helping serve these incoming requests. One slide on how this actually works. So our agents create a trace ID and sort of propagate that trace ID in the HTTP header. So as one service makes an external request to another service, it forwards the trace ID to that service so that we can later link together these requests in the UI. There's a working group, W3C Trace Context Working Group, that is currently working on standardizing the HTTP header format for distributed tracing. And that's a great initiative and something that's been missing for sure. Because you obviously want all agents to be able to link to each other or link services and requests together. And with this initiative, we're getting really close. It's not finalized yet, so the spec is not in version 1.0 quite yet, but it's gotten really far. And we are supporting this initiative, and we also have an implementation that follows the current specification. And you can see an example of it down here in the bottom. And to the fun part, so Elastic APM 6.5 now has distributed tracing support in beta. And this is what it looks like. So as illustrated before, when you dive into the APM UI, you'll be able to see not only the service that you might have navigated to, but also all of the downstream services that are part of the request it's serving. So it's a really, really powerful feature, and we're super excited to have it in Elastic APM now. Oh, looks like got an email here. So let's see. ChatOps wrote to me that there's a performance alert on the service Pet Clinic React. There's a slow performance spike detected. Let's launch APM UI and dive into it. So hopefully you can all see my screen still, even though I'm navigating to another tab. And now I'm in the APM UI. So here I'm looking at a React service. This is actually a little bit of a silly demo application we have here. It's based off the Pet Clinic, Java demo with a React front end and a node layer in between. And right now I'm looking at the React layer in the APM UI. And it does look like we have some spikes here. So if I go and zoom in on this spike, just to see what's going on, maybe I'll zoom in even more. We do see that, maybe I'll sort by the 95th percentile out here. Do see that the update owner endpoint is being pretty slow. So let's dive in and see what's going on. Maybe I'll look at some of the fast response times first. So this looks pretty good, but we do see that in our distribution of this trace, we have some very fast responses, and we have some very slow ones out here, which were the spikes that we were looking at before. But let's just first look at one of the normal traces. So here you can see we have 3 services participating here, React layer, node layer, and Spring layer, and it looks pretty good. But if I pick one of the slower ones here, you'll see that I've got all squished together out here to the right because this zip code thing is taking a lot of time. It's almost taking 20 seconds. If I go back, here it's not taking any time. It's like 0.13% of the time. Whereas here it's very slow, 99%. So that's not good. We can see it's something about a zip code validator on the Java layer. Let's see. And the response here is a 400, and there's an error here in the header. You see that the field value is a long string. That doesn't look good. Probably also generated some errors. Let me go to the error tab here. For some reason, I don't see it. Oh, I was on the React layer. Let me just go back. Go to the Spring layer. Go to errors. Yeah, we do see here, there's a few occurrences of this invalid zip code. Let's see if we can reproduce it. If I go to the Pet Clinic here and go to one of these owners, see if I try to update zip code. So that works okay, but let's see if I try to do one of these really, really slow. Hang on, let's see. Here. I try to take one of the errors and paste in like a very slow zip code here, see what happens. Or a very long zip code. Update. This is the thing that looked to be taking 20 seconds before. Probably some regex, maybe somebody's having fun here. Yeah, that did take some time. Go back to the UI here. And maybe go to the past 15 minutes. Yeah, there's a spike here again. Update owner. Yeah, we have the very slow validate zip code. And if I click in here, we'll see that the response generated another error. Okay, so we need to fix that for sure. Let's go back to the presentation. Oh, another email. That sucks. So customer support's emailing there's a customer complaint. The user is having issues with slow performance. Can you investigate? The username is Deborah. Okay, let's go and see. It does look like the baseline is pretty high here. It does look pretty like some people are having difficulties. Let's see, Deborah. 29, I think it was. Oh, what was it? Oops, sorry, Deborah. Oh, I'm in the wrong username. Deborah. They do look pretty slow, almost 2 seconds. If we go to the node layer, see, that's much faster, like 80 milliseconds. The problem is definitely on the React layer. If I zoom in on one of the transactions here generated by this user, you can see, oh, there's a lot of time spent on the React layer. As we just discovered, the node part is pretty quick, and so is the Java part. Let me click here, let's see if we have metadata. See, Deborah is using Internet Explorer. That could be a problem. So let's go back to the transactions. Let's see if we type in agent, user agent name, home, for instance. Yeah, that looks much faster. Here we don't have that high baseline of the percentile. Let's try Internet Explorer. Yeah, that looks pretty bad. That's probably something we need to fix. Okay, back to the presentation. So as you hopefully could see with that sort of silly pet clinic demo, we now do support distributed tracing, and hopefully that was clear in the waterfall. And it's super powerful with the search capabilities of Elasticsearch. We have that search query bar right in the APM UI. It makes it super easy to filter down all of your data while investigating issues on those traces. So I hope you find that as valuable as we found it while building it out. Okay, so I want to talk a little bit about how you actually get this up and running. So these are the components that are needed to get APM with the Elastic Stack. So you have an Elasticsearch cluster already. You probably also have Kibana. What you need is to have these APM agents added as dependencies to your application. That's very easy to do, and all of the agents are maintained by dedicated teams here at Elastic. So we have a team that is working on the Java agent, the browser agent, the Go agent, and so forth, and to make sure that they are always up to date and have like very minimal footprint on your application. And these agents will instrument your application and send data down to the APM server. The APM server will then process the data and store it in Elasticsearch. And then you can consume the data in either custom dashboards or in the Kibana UI, as I just did before. I don't know if you noticed, but in Kibana, there's now a dedicated APM app in the sidebar. And that's exactly what I was demoing just before. When you go to that particular application for the very first time, that being the APM app in the Kibana sidebar, you see it here, you'll be shown these setup instructions. There's a few steps to download and unpack the APM server and get that up and running, connected to Elasticsearch. And then there's a few steps in terms of, well, first choosing what language that your application is written in, and then choosing an agent that fits your need. And then you get the instructions on how to get started right within the APM UI. And it should be really, really fast to get up and running once you have the APM server connected to Elasticsearch. For Java, out of the box, we support version 7 to 11. We also support a few frameworks. You see them listed here to the left. application server and data store is supported out of the box as well. The way you get the agent attached to your application is to use this Java agent flag. So no code changes are required. If you use one of the supported frameworks and you enable the agent with the flag here, it will start instrumenting your application automatically with no work needed on your part. Just to recap what works out of the box, if you are using any of the frameworks that are listed here, the Java agent will automatically group all of your incoming requests to endpoints, and it will instrument database calls, JDBC calls, cache calls. It will do templating, external requests out of the box, and that will show up in the waterfall visualization that I just demoed before. On top of that, not only do we support JDBC, but also calls to Elasticsearch. I just wanted to mention that as well. If you don't use any of the frameworks that we support out of the box, or if you want to do some custom instrumentation, that's possible as well. The agent comes with an agent API package that you can add to your application. This, of course, will require some code changes on your part, but if you add the agent API package to your application, you'll be able to, for example, annotate methods with this capture transaction annotation, so that this method automatically will be created as a transaction and then reported back to the APM server. If any on-cut exception should happen during that method call, that will be captured as well. So this is a very easy way of getting either extra granular data into your visualization, waterfall visualization, the timeline I showed you before, or it will be a way for you to get instrumentation working if you don't use a framework or not use any of the frameworks that we support out of the box. The span I showed before with the zip code validation is actually a custom span that is created with this package. Should also note that the Java agent has an open tracing compatible bridge, so that will be compatible out of the box. I also had a bunch of React instrumentation in the demo, and that's coming from our RUM agent. And I just wanted to add one slide about that here. Having the RUM agent as part of your trace is super valuable in the sense that you can start your trace all the way out at the client level, client meaning the browser essentially, which is really the only way to understand the actual end user experience. If you have latency issues, or you could, for instance, be in a region where the latency is slow, or your front end could be like a very big bundle size, so it just takes a long time to download it, or there's parsing going on in the browser that just makes rendering and parsing the HTML really slow. That can be detected with the RUM agent, and that's really something you have a hard time getting visibility into if you don't capture it out in the wild, so to speak, because all browsers are different and people are in different regions, and it's just very hard to test on your local environment. So to get this, you can either add it as a dependency to your application by npm install, for instance, or you can download and add the JavaScript bundle and directly from us, and then have it added as a script tag and initialized that way in your HTML template. A few words on the APM server as well, especially sizing of the APM server. So we've been getting a few questions about this previously, so I wanted to address it here. It's a bit of an eye chart, and there's a lot of stuff going on here, so it'll be hard for me to go over all of this in this presentation. But hopefully this will give some guidance if you're looking to size your APM server. And remember, this presentation is available for you after the fact, so you will be able to go back and look at these after. But as an example, and I should note that all applications are different. Some applications create a lot of events, and some create a few. So you really need to test it on your own. But a APM server running with 512 RAM and 1 CPU is capable of handling almost 600 events per second. And you'll see over to the right that since the APM server is CPU bound, if you have the right settings, it will scale almost linearly with the CPU. And you might be wondering what events really mean. So going back to this slide we had before, a trace is essentially a bunch of events, transactions, and spans. And spans are very much a variable that is hard to predict from the outside. Either a transaction is doing one database query or it's doing hundreds. And the amount of those will essentially be your event count. So think of the waterfall visualization and how many spans you have in that, and then sort of map that to the events that the APM server can handle. That's sort of how to think about it. There's a bunch of ways to configure the agents so that they send fewer spans or smaller spans. And there's also, I would say, probably the most important configuration, the sampling rate, essentially meaning how many of the incoming transactions are you actually sampling, are you actually creating these spans for. For non-sample transactions, you'll only get one event. You'll only get the duration of the transaction. You won't actually get the auto-instrumentation spans. So that's a way of tweaking how much data you will be storing. In 6.5, we've also released support for monitoring. So for those who don't know, monitoring is a stack component. There's a monitoring app inside of Kibana. And the APM server will now be reporting to the monitoring cluster so that you can see here how your APM servers are performing, and use the monitoring panel here to adjust and fine-tune the agent configuration, sampling rate, and so forth. And just making sure that the overall health of your APM data is in the green. And finally, one word on licensing. The APM server and the agents are all open source. The Kibana APM UI, which I demoed before, is part of our basic distribution. So if you go download Kibana on our website today, you'll get the APM UI out of the box with the default distribution. The default distribution is free, as noted here. So it should be really fast to get started. As mentioned in the very beginning, we also have Elastic Cloud and Elastic Cloud Enterprise, and both Elastic Cloud and Elastic Cloud Enterprise will support APM down the line. I can't share like a concrete time for it right now, but we're hoping it'll be very soon. And finally, and on the minute I see, so pat myself on the back here. We have logs and infrastructure solutions out in 6.5. I mentioned that very briefly in the beginning, that we're adding these solutions to our offering. Solutions really are like use case specific UIs and solutions. And logging and infrastructure metrics are two examples of exactly that. So in the APM UI, in Kibana in 6.5, next to the APM app, you'll now see a logging and an infrastructure app, which looks like this. It's really awesome for you to tail logs, as you can see on the right, or get an overview of your infrastructure, as you can see on the left. And these are out in beta in 6.5, and something we're super excited about. I think metrics, logs, and APM is a very, very powerful combination, and we will do a lot of work on integrating these solutions so that you can see yourself going from, for instance, a distributed trace over to the logs that were generated doing, for instance, a span in that trace, or going from APM to the container or the host that was serving that request. I think that's going to be really awesome. And there's a webinar coming in December that will show off these two new solutions. So please do keep an eye out for that. And with that, thank you very much for tuning in.